Hi everyone! Today we're going to be talking about congruent triangles. Our objectives for today are that students will be able to name and use corresponding parts of congruent triangles, and you'll be able to prove triangles congruent using the definition of congruence. Let's get started. Alright, so what is the formal definition of congruent triangles? Well, congruent triangles are triangles with the same shape and size. So congruent triangles are triangles with the same shape and size. This means that all of their corresponding parts, which includes angles and sides, are congruent. All right, when triangles are congruent, we can write something called a congruency statement. So this right here would be our congruency statement. We would say that triangle ABC is congruent to triangle DEF. And a valid congruency statement must match all corresponding angles and sides. So what does this mean exactly? So what this means is if we're looking at the corresponding parts, we know that A is congruent to D because both of those letters come first in our congruency statement. Then we can say that B is congruent to E. Angle B is congruent to angle E because both of those letters come second. And then we can also say that angle C is congruent to angle F because those are both the third letter in our congruency statements. Then if we're looking at the sides, it says AB comes first here. Okay, so AB is the first two letters and DE is the first two letters. So we can say that AB is congruent to DE. And then if we're saying BC and EF, because BC is the last two letters of our congruency statement and EF is the last two letters of our congruency statement. So that's why we can say BC is congruent to EF. And then last but not least, A and C come first and third, D and F come first and third. So we can say DF and AC are the congruent sides to each other. So your congruency statement has to match all corresponding angles and sides, all right? So the first letter and the first letter, those are the angles that are corresponding. The second letter and the second letter, those are the angles that are corresponding. Third and third. Then first two, last two, first and third. All right, that is how we write a valid congruency statement. If you have any questions on that, call me over so I can help you. Otherwise, let's move on. All right, CPCTC, what is that? What does CPCTC stand for? Well, CPCTC stands for corresponding parts of congruent triangles are congruent. All right, so corresponding, there's our C, parts, there's our P, of congruent triangles are congruent. CPCTC is just the abbreviation we use so we don't have to write out corresponding parts of congruent triangles are congruent every single time. All right, extra credit point if anybody can say CPCTC 10 times fast without messing up. All right, if you want to give it a try, go ahead. So basically what CPCTC says is that if we know two triangles are congruent, then we know that all their corresponding parts are also congruent. All right, so that's what CPCTC is, and we're going to be using it a lot. All right, so directions for number 1, we want to list all the congruent angles and sides given our valid congruency statement. So I'm going to zoom in so we can see this a little bit easier. So let's start with our angles. So our first letter is J, and our first letter over here is P, because we know triangle JKL is congruent to triangle PQR. So we can say that angle J is congruent to angle P. And then we can say that angle K is congruent to angle Q, because those are both the second letters in each of the triangles. And then last but not least, we can say that angle L is congruent to angle R because those are both the third letters. All right, now if we want to deal with the sides, start with the first two letters here and the first two letters here. So JK is congruent to PQ because they're both the first two letters. Then we can say that KL is congruent to QR because those are both the last two letters. And then if we want the first and third, so JL and PR. So JL is congruent to PR because that's the first and third, first and third. All right, and then if we wanted to write another valid congruency statement, I'm going to erase this up here so we can see this a little clearer. What we would do is we would say triangle something is congruent to triangle something. And what we want to do is make sure we just rewrite them in the same order where corresponding angles and sides are congruent to each other. So the easiest way to do this would just be to say the second, third, and then back to the first. So we could say triangle KLJ. So the second, third, and then the first letter is congruent to triangle QRP. Second, third, first. All right, so that is a valid congruency statement. You could also say triangle LJK is congruent to triangle RP, or I said RP and I wrote PR. RPQ. All right, and those are both valid congruency statements. All right, if you have any questions on this, call me over so I can help you. All right, otherwise let's move on to number 3. All right, so number 3, given the triangle KPM is congruent to triangle AYC, I want you guys to try to complete each of the following statements, all right? Try to match the corresponding parts and figure out a statement that valid congruency statements for the triangles, all right? So go ahead and give this a try. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now and give this one a try. All right, so let's go through the answers for these. So first of all, A, we're saying what segment is KM congruent to? So what side? So KM is the first and the third letter, so we know that first and third has to be congruent to first and third. So KM is congruent to AC, and then we mark that on our diagram. Then CY. CY would be third, second, so third, second would be MP. So CY is congruent to MP. All right, and then we mark it on our diagram. All right, these two sides right here. Then PK. PK is second first, so YA is second first. So PK is congruent to YA, and then we mark it on our diagram. Now, which one is angle Y congruent to? So angle Y is the second letter, P is the second letter, so angle Y is congruent to angle P. Mark that on our diagram, Y and P with a single little line. Then K. K is the first letter, so A is the first letter, so K is congruent to A. Mark that, both of those with two little lines to show that those two angles are congruent. Then we've got angle ACY. ACY would be this angle right here, and the only other one that's not congruent yet is angle KMP, all right? And the order matters. So if we said ACY, first, third, second, we have to say first, third, second, okay? So ACY, we have to say KMP, all right? Then, now we're saying triangle MPK. So MPK would be third, second, first. We have to say third, second, first. So congruent to triangle CYA. And then triangle YAC, YAC, second, first, third. So it has to be second, first, third. So it has to be PKM. All right. Or wait. YAC, PKM. I actually wrote that wrong. Hold on, let me fix that. Let's see. So that has to be triangle PKM. All right. So if you have any questions on that, go ahead, raise your hand, call me over so I can help you. Otherwise, let's move on. All right, we're given this congruency statement right here. Oops. We're given this congruency statement right here. We want to find each measure. So first things first, we're given some information. So we know HG is 27, so we want to see what side is corresponding to HG. Well, HG would be corresponding to YX. So YX is this side. So this one is also 27 feet. All right. Now, we're given that HJ is congruent to HG, so HJ also has to be 27. And HJ is congruent to YZ. So YZ is also 27. So we know that all those sides are 27. Let's see if we can fill any of these in. So ZY, we found out, is 27 feet. And XY is 27 feet. Now we still need to find GJ. So we know GJ, that's our first and our third. First and third, so GJ is congruent to XZ. So if XZ is 18 feet, GJ is also 18 feet. So we filled all those in. Now, using what we know about special triangles, if the two legs are congruent, then the base angles are congruent because this is an isosceles triangle. So two angles are congruent, therefore these two base angles are congruent. So we know that Z is congruent to X, and we know that Z is congruent to J, and X is congruent to G. Now we know our base angle is 38. Okay, so this one is 38. So right off the bat, we know that H is also 38 degrees. And if we want to find the base angles, we know that the measure of angle X plus the measure of angle Z plus 38 has to equal 180. All right, now we know measure of angle X and the measure of angle Z have to be the same. They have to be congruent, okay? So let's just call them, let's use a variable we haven't used yet. Let's call them T, all right? We can use anything, or let's use A for angle, all right? Angle plus 38 has to equal 180. So 2 times the base angles plus 38 has to equal 180. So subtract 38 from both sides, and we get that 2A equals 142. Divide both sides by 2, and A equals 71. All right, so each of these base angles, X and Z, have to equal 71 degrees. All right, another way you could have done it is just said 180 minus 38 gave you 142. Divide that by 2, so we know that each of them has to be 71. All right, essentially that is what we're doing with that giant equation, okay? If you have any questions, call me over so I can help you. Otherwise, let's move on to number 7. All right, so I want you guys to try number 7. You are given this congruency statement right here. Find the values of X, Y, and Z. When you come back, I'll have the answer written on your screen, and we will go through it together. So go ahead and pause your video now and give this one a try. All right, so you should have gotten that X is 24, Y is 10, and Z is 17. How did we get that? So first thing we did was look at our congruency statement and see which angles are congruent to each other. So P is congruent to C, so we mark that on our diagram. H is congruent to N, so mark that on our diagram. And S is congruent to F, so mark that on our diagram. Then we want to first solve for X. So we know that this angle right here is 6x minus 29, and we know it's congruent to the angle that's 115. So 6x minus 29 equals 115, and then we can solve for X. Then to find Y, we know that this angle and this angle are congruent to each other, and we know that this has to be 29, because if this one's 115, this one's 130, this one's 36, add them together and we get 151. 180 minus 151 gives us 29. So we say 3y minus 1 equals 29. Solve for Y. Then, last but not least, to find Z, we set angle C equal to angle P and solve for Z. All right. If you have any questions, call me over so I can help you. Otherwise, let's move on to number 9. All right, so number 9, we're not given a picture, we're just given words. So first thing you want to do is draw a picture. We know we've got 2 triangles here. We've got QRS and MNP. So we want to label them. Draw them and then label them. QRS and MNP. All right, then we want to label what we know. So first of all, we know that all of these angles, Q and M, are congruent, R and N, S and P. Then we know that QR is congruent to MN, RS is congruent to NP, and QS is congruent to MP. All right, then label what we're given. We're given that QR is 11, QS is 15, MP is 2x plus 1. The measure of angle S is 84. The measure of angle R is 32 degrees. And the measure of angle M is this one right here, and I'm just going to draw an arrow and do it down here, 17y minus 4. Find the values of x and y. So what we want to do is first find x. Now we know that QS is congruent to MP, all right, because of our congruency statement. So we can say 2x plus 1 equals 15, and that will allow us to solve for x. All right, so if we didn't have a picture, this would be very challenging. All right, so always draw a picture. So x equals 7. Then what else do we know? We know that R is 32 and S is 84. So in order to find the measure of angle Q, what we would need to do is add them together and subtract from 180. So we can say that 84 plus 32 gives us 116. 180 minus 116 gives us 464. All right. Then if this is 64, we know that Q is congruent to M. So we can say 17y minus 4 is equal to 64. All right, so we set that up. Add 4 to both sides. These will cancel out. 17y equals 68. Divide both sides by 17. And y equals 4. And we just solved for x and y. So now we're done. All right, then just want to go over a couple things, just kind of reiterating what is a valid congruent statement and what is not a valid congruent statement. All right, so a valid congruent statement right here, first and first, second with second, third with third. So we can say B is congruent to J, angle C is congruent to K, angle A is congruent to H. All right. This is not a valid congruent statement. So we can't say first and first, second and last and, what would that be? Last and second. All right, this is not a valid congruent statement if you're given triangles. All right, it has to be in the same order. They have to be corresponding angles and corresponding sides. All right, and then just going over a couple more theorems, or one more theorem that your book covers, but is not included in your notes. So I just kind of want to go over the third angles theorem. So the third angles theorem tells us that if we know 2 angles in one triangle are congruent to 2 angles in a second triangle, then we can automatically say that the third angle is congruent to each other. All right. So for example, if we're given that C is congruent to K and B is congruent to J, by the third angles theorem, we can say that A is congruent to L, because we're given if 2 angles are congruent, then that third angle is also congruent. This is the third angles theorem. All right, so this is something that may come up that we may need to use when we're doing proofs. So you need to know this. All right, and last but not least, properties of triangle congruence. I know congruence is spelled wrong here. I'm sorry, okay? So going back, you've seen all these before: reflexive property, symmetric property, and transitive property. They also apply to triangles. So reflexive property of triangle congruence says triangle ABC is congruent to triangle ABC. It is congruent to itself. Symmetric property says if we say triangle ABC is congruent to triangle EFG, then we can say triangle EFG is congruent to triangle ABC. So symmetric property, we can switch them around, and it's still the same. Okay. Then last but not least, transitive property applies to triangles too. So if ABC is congruent to EFG, triangle EFG is congruent to triangle JKL, they're both congruent to triangle EFG, so we can say that triangle ABC is congruent to triangle JKL. All right, so reflexive, symmetric, and transitive property also work with triangle congruence as well. All right, so I hope you learned a thing or two about congruent triangles today. If you have a question about anything, call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye.